These exercises use the radioactive decay model, where the mass after time t is equal to the initial mass times 2 to the opposite of t over h, where h is the half-life. The first part of the problem gives us that the half-life of strontium-90 is 28 years, so 28 is our h. How long will it take? So we're going to be working with a variable t. For a sample of 50 milligrams of strontium-90 to decay to a mass of 38 milligrams. So the original mass is m sub 0, and that's our 50 milligrams, and our mass at time t is the final mass, which is 38 milligrams. So substituting these values into the equation that we were given, we have 38 equals 50 e to the opposite of t divided by 28. I'm going to divide both sides by 50, which gives 38 over 50, or 76 over 100. So we get 0.76 as the decimal answer here. I would not use the decimal if it did not terminate. I would continue to use the fraction. But in this case, we get 0.76 equals, and I wrote e and I meant 2, so let me get that fixed. The formula is uses a base of 2, and so we have 2 to the minus t over 28. Now I'm going to take the log base 2 of both sides. Log base 2 of 0.76 equals the opposite of t divided by 28. And remember that the log base 2 of 2 to the power leaves the power, because the log and exponentiation with the same base are inverses of each other. And so we can multiply both sides by negative 28 and get negative 28 common log of 0.76 over log 2. There I've used the change of base formula. That's the common log of 2 in the denominator, equals t. And we can get an approximate answer for t using our calculator and entering negative 28 log 0.76, close the parentheses, divide log of 2. So log parentheses 2, close the parentheses, and enter. And we get 11.09 years, or approximately 11 years. All right, so going to the second example, we first of all will identify our variables. It says if 250 milligrams of a radioactive element decays to 240 milligrams in 10 hours, find the half-life. So this time, our m sub 0 is 250. Our t is equal to 12, and the 240 is the mass at time t. And so the equation that we have is 240 equals 250 times 2 to the opposite of 12 over h. And h is what we're looking for, the half-life. And so 240 divided by 250, we're going to divide both sides by 250. That's the same as 24 over 25, or 96 hundredths. Equals 2 to the negative 12 divided by h. I'll take the log base 2 of both sides. So log base 2 of 0.96 equals the opposite of 12 divided by h. So I'm going to multiply both sides by h, and I'm going to use the change of base formula on the log base 2 using common logs. So I'm going to have h log 0.96, that's a common log, divided by log 2, common log of 2, equals negative 12. Now I'm going to multiply both sides by the reciprocal of log 0.96 over log of 2. That's going to isolate the h and give me the negative 12 times log 2, common log of 2, divided by the common log of 0.96. And we can work this with the calculator. Sorry. Here we are. And it's going to be negative 12 log 2 divided by log 0.96. So negative 12 log 2, make sure that you close the parentheses, divided by log 0.96, close the parentheses, and hit enter. And we get 203 3/4 years approximately, but we're working to the nearest whole number, and so we are going to have 204 years. So approximately equal to 204 years. And in the last problem, a wooden artifact from an ancient tomb contains 70% of the carbon that was present in the living tree. How long ago was the artifact made? We're given what the half-life is. It's 5,730 years. We don't have a specific weight, but what we know is that the mass at time t equals 70% of the mass at time 0, of the original mass. And so we're going to look at the formula m of t equals m sub 0, 2 to the opposite of t over h. And for m of t, we're going to have 0.7 m sub 0 equals m sub 0, 2 to the opposite of t divided by 5,730. Now we can cancel the m sub zeros, and we get the log base 2 of 0.7 is equal to the opposite of t over 5,730. Now I'm going to multiply both sides by a negative 5,730 to get negative 5,730, and use the change of base formula. So common log of 0.7 divided by common log of 2 will be equal to t. And then I can find the approximate value there to the nearest whole number using the calculator. We have negative 5,730 log 0.7, close the parentheses, divided by log 2. Close the parentheses, hit enter. And so we're getting that the value of t is approximately 2,949 years. 2,949.